Hello everyone, this is Ketish here. In this video, I'm going to go through the AQA Physics Paper 1 Higher Tier from 2023. Question number 2 is on the topic of energy, just to do with specific heat capacity. Now, this is actually a required practical that you should know. Figure 2 shows the equipment a student used to determine the specific heat capacity of iron. The iron block the student used has two holes, one for the heater and one for the thermometer. So you have the thermometer here and the heater. The iron block is connected to a joule meter, which in turn is connected to the power supply. So the way it works is the power supply, the energy that is coming through the power supply goes through the joule meter and then to the iron block. So whatever energy that is passing through to the iron block is actually recorded in the joule meter. Now the joule meter is actually supplied by a different power source, so which means that it's not using any of the energy that is coming from the power supply here. Before the power supply was switched on, the thermometer was used to measure the temperature of the iron block. The student left the thermometer in the iron block for a few minutes before recording the initial temperature. Suggest why. Now, the thermometer, which is usually, if it's outside, it will be recording the room temperature. Now, the iron block, it's being a metal, is slightly going to be cooler. So you want the temperature to be equal, or the thermometer to record the temperature of the iron block. So you want to leave it a couple of minutes for the temperature to be able to stabilize or to record. So the answer for mark, so the thermometer temperature was the same as the temperature of the iron block. Next question. Figure 3 shows how the temperature changed after the power supply was switched on. And we have a graph, and the graph on the y-axis temperature in degrees Celsius and the x-axis is time in minutes. So you can see it starts off at 20. The temperature is more or less the same for about 2.5 minutes, and then it slowly starts to increase linearly, and then it stops at 80 at about 15 minutes. Question. The energy transferred to the iron block between 5 and 10 minutes was 26,000 joules. The mass of the iron block, which is M, that's E for energy, was 2 kilogram. Calculate the specific heat capacity, which is C. Use information from figure 3 and the physics equation sheet. Now the equation that you need is energy equals mc delta theta. So the mass, specific heat capacity, and the change in temperature. So the energy they have given you that here, the mass they have given you that there. The specific heat capacity is what we are trying to find out, and the temperature change, we need to find it from the graph. So the temperature change for the 4 marks has to be found from the graph between 5 and 10. So at 5, the temperature is, now there's 5 boxes for 10 degrees. So 10 divided by 5 is 2 degrees Celsius. Each box is 2. So that's 28 degrees Celsius. And at 10, that's 54 degrees Celsius. So we can find the difference between those two values, find the temperature change. So 54 minus 28 equals 26 degrees Celsius. So energy is 26,000, sorry, equals 2 times the specific heat capacity multiplied by 26. Rearranging the equation, specific heat capacity equals 26,000 divided by 2 times 26 in brackets, and that should give me a value of 500 joules per kilogram. 500 joules per kilogram degrees Celsius. Next part. The student repeated the investigation but used wrapped insulation around the iron block. What effect will adding insulation have had on the investigation? Now, as part of the experiment, you should be wrapping insulation so that you don't lose any heat from the iron block to the surrounding. The calculated specific heat capacity will be more accurate, yes, because you're not going to be taking into account the heat that is lost to the surrounding, or you're going to reduce that. The iron block will transfer thermal energy to the surroundings at a lower rate. Yes, that would also be correct. Now, just to check the next three options, the power output of the heater will be lower. That's controlled by the power supply. The temperature of the iron block will increase more slowly. Not necessarily, it will actually be faster. The uncertainty in the temperature measure will be greater. That's due to the equipment. So it's the first two options. That brings us to the end of question number 2, and I will see you in question number 3.